Alright, so what we're going to draw here is a bend of the universe, bend of space-time. Alright? Now right here, what we have, this is going to represent the black hole. And this is going to represent our white hole. This point right here is called a gravitational singularity. We're just going to call it singularity. Singularity. Alright. Now this black hole, label it B and W for white. Okay, these points right here, these are called your event horizons. Horizons. Okay, so what we have here, a black hole, the whole thing about a black hole, it literally absorbs everything that comes across its path. It devours whole stars, whole entire galaxies. But here's the different thing about a white hole. A white hole spits it all out. A white hole, nothing can enter a white hole. It only spits out stuff. So what the black hole does, it sends it in, it gets compressed by the singularity. A gravitational singularity is an infinitely small point. And then it gets compressed out into the white hole. Supposedly another universe, another part in space-time. Alright, so what we're going to have here, draw another model, is called the Einstein-Rosen bridge. Okay? Now the only problem with this is gravity itself. Gravity is what's making the singularity. Gravity compresses this so there can be no Einstein-Rosen bridge, aka wormhole. So what we need is something to keep that open. Alright? What we're going to title this for now, we're going to title this exotic matter. So, exotic matter. Okay? What you have here, every once in a million chance time, a black hole will form by the compression of a star. When a star is when a star meets the end of its life cycle, it compresses, and then sometimes, according to its mass, if it's heavy, if it has enough mass, it can form into a black hole. And a white hole can be formed on the other side. Okay? So, what do we have for exotic matter? Alright, what we need is something that's completely negative. Some negative form of matter. But all the matter we know of, all the matter is positive. That's just the way our brains work. This is called an energy condition. Alright? But an energy condition isn't a law. It's a condition. That's why it's called an energy condition. So, therefore, if we find something, it's not impossible. It's not impossible at all. So, if we find something, in further research, I researched, we have a perfect candidate. I want to call this the vacuum of space. The literal vacuum of space would be the perfect candidate for this exotic matter. So if we could make, if we could shove some type of artificial vacuum of space type thing into a black hole, then it would theoretically, this is all theoretical, it would theoretically expand the singularity and would create the Einstein-Rosen bridge. And that's the whole theory behind a wormhole.